Bottling plants are very important constituents of food and beverage industry. They ensure quick, safe and hygienic packaging of beverages to be transported all over the world. Hi, I am Tapan Upadhyay, a BTech third year student in the Department of Electrical Engineering from Aligarh Muslim University, Aligarh. And today I am going to demonstrate automatic filling and capping in a bottling plant. This training project is developed in the newly established Industrial Automation Lab in the Department of Electrical Engineering, AMU, and it is sponsored under TechQuip 2 by the Ministry of Human Resource and Development, Government of India, National Project Implementation Unit, and the World Bank. The technical guidance is provided by ZMS Technology, Germany. So, here we see the project overview. First, I am going to take up the real-world problem description, followed by the automation concept, programmable logic controller, then moving on to the visualization in HMI or SCADA, and further steps for this project. Talking about the real-world problem where the requirement is to fill a specific amount of liquid in a bottle and then capping of the filled bottle. The filling and capping of bottles must be in continuous batch process. Earlier, this process was done manually, a very time-consuming and inefficient procedure. As soon as the process is started, after pressing the start button, the motor activates and the conveyor belt begins to move. A digital sensor senses the bottle and actuates the liquid filling arm. The filling will be done after a fixed time duration. After that, the capping arm is actuated and the filled bottle is capped. After the batch is completed, the motor and subsequently the conveyor belt stops. Also, there is an emergency stop button to stop the plant in case of an emergency situation like damaged bottles, etc. Now let us take a look at the automation concept. This is a three-phase power supply which is energizing the conveyor belt motor. In order to start the system, these are the start-stop buttons. Then we have a digital sensor installed which senses the bottles. We are also having a Genitza power quality analyzer in order to prevent the bottling plant being damaged from poor power quality such as overvoltage, undervoltage, etc. Next we have our programmable logic controller, that is the main intelligence. All the digital signals are connected to the PLC via the hard wiring. For monitoring and control, PLC is connected to the visualization system, which may be either HMI or remotely via SCADA system. In our case, it is Siemens touch panel. Basically, PLC receives a digital signal from the sensor and it generates an actuating signal for operation of motor according to the logic. The project engineering is divided into two parts. The first part involves the programming of PLC using Siemens totally integrated software. Second part is about the development of suitable screens for overall visualization of the system and using Siemens WinCC Flexible. Before we proceed further, let us get familiar with the hardware used. As you can see, this is the S7-300 PLC. First unit is the power supply unit with single phase 220 volt AC as input and the output is 24 volt DC. On the second slot is the CPU which is S7-314C 2PNDP. It has multiple communication interfaces as Ethernet interface and a Profibus interface. And there are modules for analog and digital input output, and on the last is the unmanaged switch. Below you can see the simulator buttons for digital input and output. And here this is the integrated touch panel which is our Siemens TP177B. It has Ethernet interface and Profibus GP interface. In our entire project we have used Profinet, so we have only Ethernet connection. Now let's have an insight to the programming part. You can see our CPU as Siemens 314 C2PNDP from the catalog. Right here. This is the Profinet interface and here you can see the IP address. We have 0, 1 and 2 bytes for input and 0 and 1 byte for output. Now let's see the PLC tags. These are the tags that we have defined for digital input and output. These are memory markers which corresponds to intermediate memory states. We also have defined some HMI tags so that the process can be directly controlled by HMI. Now, this is our main block where programming is done. The language used is functional block diagram, that is FBD. The entire block is divided into 7 networks, including 2 networks for HMI control, that is network 6 and 7. The first network shows the block for starting of motor with input from both PLC and HMI. Here are the digital input for motor, start stop and bottle sensors. The rest are the subsequent networks are, as you can see, since the limited time do not allow us to explain the whole logic involved in the programming, So we simply download it to the PLC and demonstrate the live working. Now the program is getting downloaded. Now coming to the visualization part, we are having two screens, start screen and the process screen. These are the tags that we have defined for depicting the ongoing process. The acquisition cycle is kept as 1 second. There is a logical connection between PLC and HMI. The connection interface is the Ethernet cable, and these are the IP addresses for PLC and HMI device. This is the start screen giving you a brief overview about the project and the project author. This is the main screen and shows start and emergency stop buttons. It shows the filling and capping of a batch of 10 bottles. Now let's download it to the HMI to have a standalone operation of PLC and HMI. Now the project is getting downloaded. So now we are ready to see the live working of the project. Here you can see this is the start screen of my project. It gives the project information and the information about the author, that is me. Now let's start with the process. As soon as I press this automatic bottling and capping button, then we enter the main screen. Here we have a start button, an emergency stop button to stop the process in case of an emergency. Now I will start the process by pressing the start button, and as you can see the process starts. The bottle is filled as soon as the bottle comes under the filling arm, and capping starts when it moves under the capping arm. Now this is a batch of 10 bottles and it will be completed when all 10 bottles are filled and capped. Now suppose there is an emergency situation in a project, so we'll simply press the emergency stop button to stop the process. Now there will be no filling, no capping, and neither the movement of belt. To resume the process, we'll have to press the emergency stop button again, and the process will continue. So this was all about the visualization part. Since improvement is a never-ending exercise, there are a few steps that can be further implemented to make the project more advanced. The PLC can be remotely accessed over 3G network or broadband internet. Since we are using the internet connection, we will be in sore need of cybersecurity. A live model to control the amount of liquid and the number of caps for different batches of bottle is a further step in this project. So this was all about the automation in bottling plant. I would like to thank Almighty God who gave me the potential to work on this project, and I would like to extend my gratitude to the Department of Electrical Engineering, Aligarh Muslim University to provide such an excellent automation lab. I also express my heartfelt thanks to ZMS Technology for immense technical and moral support. I would also like to thank my co-trainers, technical and non-technical staff of the department, my batchmates and my parents for supporting me at every step of my life. Thank you, and don't forget to watch other videos.